Hello and welcome to my presentation on the impact driver and the breakdown of its parts. The model of this impact driver is the Makita 18V LXT. You can see it on the right there. The purpose of an impact driver is it's pretty similar to a power drill, although they're not the same. They don't look quite the same. It looks a little bit smaller, but the purpose of an impact driver is it can output much more torque than a normal power drill, where a lot of applications, a power drill will work, but in some applications, an impact driver would be much more helpful as it's spring loaded and it can output, as I said, up to like 3 times as much torque as a normal power drill can. So the machine components I'm going to be looking at are the compression spring that powers the spring-loaded hammer mechanism, the spur gear that transfers power from the armature to the hammer mechanism, and then this tapping screw that holds some of the pieces together on the back of the design. So here we can see a system diagram, and I've outlined each of the parts with red circles there. And as you can see, we'll start with the compression spring. It fits in together with a lot of other parts around it. Part number 19 right here. Part number 19 is the hammer, and this compression spring is loaded and then with the use of the spur gear, and that will cause the torque and the hammer anvil system to work, but it only kicks in if a certain amount of torque is required. Otherwise, it'll just work like a normal drill. Then we have the spur gear. The spur gear connects with this internal gear, number 30, and the internal gear is spun by the armature. And as I said before, spur gear helps with the compression of the spring. And then this tapping screw, it goes in the back cover of the impact driver, and it's used to just hold on the back cover to the rest of the machine. So for mechanical advantage, I've outlined the inputs and outputs of the system. So as the name implies, it's powered by 18 volts. It's a battery pack separate from the actual device that can be changed out. And it's a lithium ion battery. 18 volts is generally a little higher than most power drills. A lot of them are powered by 12 volts, I believe, but some impact drivers, due to the high torque output, need to be powered by 18 volts. And then the output can be up to 1,460 inch-pounds of max torque, which is quite a bit, more than you'd ever need in most situations, but in some situations it's necessary. And it can also go 0 to 2,900 reps per minute, revolutions per minute, and then 0 to 3,500 IPM. IPM stands for impacts per minute. So the spring is loaded and unloaded up to 3,500 times per minute. So I've created some free body diagrams for the spring. Done my best here to sort of visualize what the parts are doing. So we have the normal force. So the force from the user, which means basically when you hold the trigger down, the armature is gonna spin with the use of the brushes. It's a brush DC motor. And it's gonna compress the spring, and the normal force from the actual impact is gonna compress it. And then you have the force from the spring that acts out in either direction. And this happens, as I said, up to 3,500 times per minute. Here's the free body diagram for the spur gear. As I mentioned before, the spur gear is connected with an internal gear, which has it's connected to the internal gear through the outside. And here's a crude drawing of how it interconnects with that. Again, I did my best. I'm not any sort of an artist. And so the force of the internal gear will cause this to turn. The internal gear is spun by the armature. And then here is the free body diagram of the tapping screw. So it's a self-tapping screw. Not that that's super important because you can just screw it in and out. The body's actually threaded that it goes into. But the main point of this tapping screw is to make sure that the back cover doesn't fall off during use of the machine. And so the recoil from the impact is then counteracted by the threading force from the screw, and it keeps everything nice and tight. So I'm going to go into the specifications for each different part here. We have the compression spring. It's 1 inch by 1 inch. Music wire steel. The dimensions, as I said, are 1 inch by 1 inch, and the wire diameter is 0.112 inches. And the spring rate is 131 pounds per inch, which is incredibly high, which is how you get that incredible amount of torque and impact mostly through the spring. Here's the spur gear. It's made out of 1144 carbon steel. It has 22 teeth. The pitch is 16, and the pressure angle is 14.5 degrees. And then here's the tapping screw. Screw size number 2, material is stainless steel, and the length is 5/16 of an inch. And approximately threads per inch is 32, pretty close to 32 at least, according to McMaster Carr. And yet all these measurements are taken from McMaster Carr. And for my design improvement, there were a lot of complaints about the brushes burning out a lot on this device. As you can see on the right, we have the armature and then the carbon brushes that create the electrical current to drive the motor, or create the spinning motion to drive the rest of the impact driver. And there's a lot of complaints about having to replace the brushes on the motor often because they burn out or they just wear out. And so the solution to this would be to exchange the motor for a brushless DC motor, which is simple enough, which has some drawbacks, but for the most part would probably work if they developed one to work for this system. And that is all. Here are my references. A lot of my parts are from ereplacementparts.com, which is where the assembly breakdown and a lot of the part information is from. And then McMaster Carr was used for all the rest of the part specifications. That is all. Thank you for your time.